One of my least favorite things about math as a sixth grader, if I could remember going all the way back to those ancient times, was that there was always one right answer. With equivalent fractions, a lot of times we give you problems where there's actually an infinite amount of answers. You'll see what I mean. This purple bar going across the top here, that represents one whole. So how much do each of these green bars represent? They're going to represent half, right? There's two of them. So each one is going to represent an equal amount. They represent one half. Now, since there's four of these red bars, what would they each represent? They would represent 1/4. And then the ones at the bottom here would each represent 1/8. So if we wanted to come up with an equivalent fraction for 1/2, I can just look right here at my picture. 1/2 is equal to two of the red squares here, or red rectangles I should say, and that's going to be 2/4. Alright, and 1/2 also equals four of the blue rectangles at the bottom. So 1/2, we could say, equals 1, 2, 3, 4/8. And the reason I say that you can get an infinite amount of equivalent fractions, all I'm doing is multiplying by the same amount at the top and on the bottom. I'm multiplying by 2 here, and on this side I'm multiplying really just by 4. And you can pick whatever number you want, and that will actually get you an equivalent fraction. So I could multiply by 100, I could multiply by 37 if I felt crazy enough, I could multiply by 67, whatever you want. Pick your lucky number, and that's how you can get equivalent fractions. Sometimes, though, you can't get unlimited answers, and these problems over here are a case of that. But they're not too bad. If I look at 4, how do I get from 4 to 12? I multiply by 3. So what do I have to do on top here? The same thing. Multiply 1 by 3. So the missing number would be 3/12. Right here, I multiplied my numerators by 4. So if I multiply those by 4, I look over here and multiply this by 4. To 5 from 15, I do times 3. 11 times 3, that's 33. And then finally, to get from 7 over 20 to something over 100, well, 20 times what equals 100? It would be times 5. And so I do the same thing up here. 7 times 5 is going to be 35. Now a word problem. What would a word problem look like for something like this? A recipe calls for 1/2 cup of sugar and 4/8 cups of flour. Does a recipe use more sugar or flour? Well, this one I'm just going to write out right here. 1/2, and then I have 4/8. What did I do to get from 1/2 to 4/8? Well, I just multiplied both parts by 4. So, really, these are the same fractions.